with this particular test. The F statistic for this test, the comparison of the two sample variances, was 2.501, and the significance value is 0.117. So let's just keep in mind, every test that we undertake, there is a null and an alternative hypothesis. And more importantly, all the null hypothesis associated with all of our tests is one of no difference at this stage, or more importantly, is the one of equality. And for us to reject the null hypothesis in favour of the alternative hypothesis, the significance value, or the p-value associated with our result, must be less than the predefined significance value of our test. In this case, for all of our tests, we have predefined a significance level of 5% or 0.05. So for us to reject the null hypothesis associated with the Levene's test for equality of variances, our p-value, the probability of observing this particular sample data, must be less than 0.05. And clearly we can see in this case it's not less than 0.05, it's 0.117. And as such, we'll proceed under the assumption of equal population variances assumed. So we're going to proceed with the interpretation of our t-test for equality of the means, assuming equal population variances. So we're going to interpret this row here in our t-test for equality of means. I suppose at this particular stage there are just three values or three columns that we're interested in, and also for reporting purposes we'll be interested in these three columns. There's the column labeled T, there's the column labeled DF for degrees of freedom, and there's the column labeled SIG two-tailed, which represents the p-value of a two-tailed test for equality of means. Okay, so we're going to interpret the results along the first row because our Levene's test has assured us with 95% confidence that we can assume that the samples have been drawn from populations with equal population variances. And for this particular result, I suppose really what we're interested in is we're interested in the significance value of this test, or the p-value. Now once again, like the Levene's test and like all of our tests, the null hypothesis or nil hypothesis associated with a t-test for equality of means is one of no difference. In other words, the null hypothesis is we assume that the populations that the two samples have been drawn from have equal population variances. Or another way of saying that is that on average the perception of males is the same as the perception of females with respect to their working conditions. Now for us to move away from that particular position, that default null position, the significance or the p-value associated with our test must be less than 0.05. And clearly in this case you can see that the significance of our test is 0.00. Actually, it's a very, very small number. We can actually see the pop-up here, highlighted yellow. It's 4.3719 by 10 to the minus 16. So the probability of observing these particular differences is very, very small if the null hypothesis was actually true. So our decision is, if our significance is less than 0.05, we reject the null hypothesis. In this particular case, our significance value is considerably less than 0.05, and as such we will reject the null hypothesis in favour of the alternative hypothesis, which is that there is a significant difference between the two means of these samples. Yeah? In other words, there is sufficient evidence to suggest that these two samples have been drawn from populations with different means. Okay, so let's actually just go back to our main output window, and really at this stage what we're saying is that this 30.48 here for the males, the average score for the males on the employee's working conditions perception, is significantly different to the 23.45 associated with the females on the employee working conditions perception. And that's significantly different as a result of this independent samples t-test. Okay, I hope that particular video was informative, and I would ask you maybe to tune into one of the other videos within this particular series on how to conduct many of the other types of tests that we can do within SPSS. Okay, thank you for your time.